All right, welcome to our next lesson in Chapter 12. This is Section 12.7, or Probability. I want you to start thinking, and I want you to actually pause, think on this for just a second. How would we determine how likely a coin is to land on heads? So think about this for just a second here, and then we'll meet back up. All right, well, some of you hopefully thought about, well, what if we tried flipping a coin a ton of times and seeing what happened? Maybe the first time it lands on heads, second time it lands on heads, and then it lands on tails, and tails again, and then heads. And what we can do is we can say, well, it landed on a tails, or it landed on heads 3 times total, and we tried this 5 times. So we might be able to say that this can happen 3 out of 5 times. Now, this is the idea that we're going to be approaching when we're discussing probability. Probability is a field of math that comes up pretty frequently. So for all of you asking, when will I ever use math? This is one of those areas where you'll see it showing up much more frequently. Now first, let's discuss some of how this relates to probability. First of all, we have something we call an outcome. And what is an outcome? It's the result of a single trial. So looking back at the trials, and a trial is just a fancy way for what we say is an experiment or a single time we're doing this. Looking back at these trials, the outcome for the first trial would be heads. The outcome for the last trial would be heads. The outcome for the third trial would be tails. Right. One of the other terms we have is something we call a sample space. And all a sample space is the total or all of the possible outcomes. So it's all possible different events that you can have when you flip a coin or do whatever else you're doing. In this example up here, all possible outcomes. What are the possible outcomes when we flip a coin? Well, it can either land on heads or it can land on tails. You might also say it could land on a side, and we might consider that as part of our sample space as well. Then finally, our last term is an event. And what an event is just one or more outcome combined. All right, so let's take a look at some of these. Let's take another example. Now let's say you're rolling a die and you're looking for an even number. Now, what are the outcomes for rolling a die? What are the possible results? Well, when you roll a die, it can come out with either a 1, a 2, a 3, a 4, a 5, or a 6. Excuse me, this is our sample space. When we're looking at this, our sample space, all the total possible outcomes is 1 through 6. Now our outcome, what would be the result of a single trial? That could be, let's say the first trial we roll a 1, the second trial we roll a 6, next one we roll a 3. So any one of these could be an outcome. Any part of the sample space could be an outcome. And what about the event? What are we looking for? We're looking for an even number. So what outcomes give us even numbers? 2, 4, and 6 give us an even number. Now these are all terms we will be using when we're looking at what we call probability. Now, what is probability? Well, probability, all it is a measure of how likely an event is to occur. We measure probability on a scale from 0 to 1. So we measure probability on a scale from 0 to 1. And we think of probability as either a decimal or a percent. So 0 right, if we made that into a percent, would be 0%. What's a 0%? Well, it means that it's not going to happen. There's a 0% chance this is going to happen. What about for a 1? If we convert 1 into a percent, it becomes 100%, meaning that whatever has a probability of 1 or 100% is always going to happen. What about if we went to 1/2 or 0.5? Well, when we convert that into a decimal or into a percent, that becomes 50%, meaning that this one is equally likely to happen or not happen. So probability shows up between 0 and 1. It's usually a decimal, but you can think about it in terms of a percent. Now we have two different types of probabilities. The first one of those is experimental. The second type is theoretical. So for an experimental probability, which we shorten down to just being p or p of something, for an experiment, it's the number of times something occurs and then we divide that by the total number of times we checked, or the total trials. So for an example, if we're looking back at flipping a coin and we see that we land tails, 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 heads, tails, the probability, we write that as p, and we put in parentheses what we're looking for. So the probability of landing tails will be equal to, how many times did it occur? 4 times. And how many times did we try this, or how many times did we run this? Well, we ran it 5 times. So this would be an experimental probability. Whereas a theoretical probability, when we put that in, that's going to be the number of favorable outcomes, or the number of outcomes where you win, and we're going to divide that by the total number of outcomes. And remember, an outcome is just one of the possible things that you could get out of any trial. So let's say we're looking back at a die, or we're rolling just one die. The probability of getting an even, and this is how we write it, p meaning probability, whatever we want to look for is in parentheses. So the probability of being even, what are the total chances, or what are the ones where this comes out even? That would be 2, 4, and 6. What are the total outcomes? Well, we have 1, 2, 3, 4, 5, and 6. So how many favorable outcomes do we have? We have 3 of them over how many? 6 total, meaning that this probability is 1/2. So we have these two different types of probability. Experimental, where we're looking at a total set and we're seeing how many times it occurred over that group, or theoretical, where we say, hey, this can occur in 5 different ways, and there's a total of 10 different ways that we can actually do it. All right, let's look at some examples of this. For example, what's the probability of rolling a 5 on a die? So this is going to be a theoretical probability, a probability where we look at the total number of outcomes where we get a 5. How many times can we get a 5 on a die? Well, there's just one option for that. We roll a 5. How many different ways can we roll? Well, we can roll a 1, 2, 3, 4, or 5, meaning that there's 6 different options. So our probability for this is 1/6, or we can write that as 0.166 repeating, or we can write that as 16.67%. Any of those will work. Now let's look at another example. Let's say you're grabbing drinks from a cooler and there were 35 sodas. there were 10 juices, and there were 5 waters. What's the probability of grabbing a water? Well, the probability of grabbing a water will be the total number of ways we can grab a water. There are 5 different options for us to grab waters, but how many different choices do we have to grab? Well, there's 5 waters, there's 10 juices, and there's 35 sodas. So the total number of drinks we can grab is going to be the 35 sodas, the 10 juices, and the 5 waters. Or our probability is going to be the 5 waters over the total number of drinks, which is going to be 50. So our probability of a water is going to be 1/10, or 0.1, or 10%. All right, let's look at one more set here. This time we're going to be looking at cards. For those of you who don't know, in a deck of cards, we're going to say there are 52 cards. This is normally correct. You might count jokers, but we're not going to do that. Now these cards are split into 2 different groups. You have the red cards and the blue cards, or the black cards. If these are evenly split, which they are, that means there are 26 red cards and there are 13 black cards. Now within the red cards, we have 2 different suits. We have a suit of hearts and we have a diamond suit. Once again, both of these are split evenly in red, meaning that there's going to be 13 in each of these. Now black also has 2 suits. It has spades and it has clubs. Each of these also has 13 cards. Now within each of these, each suit will have those 13 cards. It will start with 2 and work its way all the way up to 10 before you get your face cards, where you have Jack, Queen, King, and Ace. So each of the 52 cards is either red or blue or black. Not 26 cards, there are 26 in there. So your cards are either red or black. They're either hearts, diamonds, spades, or clubs, and they can be a 2 through 10 or a Jack, Queen, King, or Ace. So if I were to ask, what's the probability of pulling a red 2? The probability of pulling a red 2. How many red 2s are there? Well, there is 1 heart, or 2 of hearts, which is going to be red, and there's 1 diamond of hearts. 2 of diamonds, excuse me here. So we have a 2 of hearts or a 2 of diamonds. There's 2 possible choices that we can have. And how many cards are there total? There's 52. So we have 2 chances to grab this, and we have 52 chances overall, meaning that this, when we divide it down, becomes 1/26. What about if we're looking for the probability of pulling a jack? Well, each of these suits has a jack. So you have a jack of hearts, a jack of diamonds, a jack of spades, and a jack of clubs. There are 4 different options for you to pull, and how many cards can you pull? There's 52. Now when we reduce this down, what do we get? That becomes 1 in 13. And then what about if we were looking for the probability of pulling a diamond? Well, how many diamonds are there? There are 13. How many total cards do we have? There are 52. So the probability of pulling a diamond is there's 13 diamonds we can pull out of the 52 total cards, where this becomes 1/4. All right, so that's all we have for probability. We have those 2 different types, the theoretical, where we're looking at the total different groups and how many are going to be favorable, versus the experimental, where we're looking at the total number of times something showed up out of the total number of times we looked for it. Let's give you guys some practice problems to get some work with this. All right, now you flipped a coin and you found out that it was heads the first time and the second, tails, then heads, then tails, and tails. And we're trying to find the probability that will flip a heads. Now, looking at a deck of cards, I also want you to tell me what is the probability going to be that we pull, this is for a die. So looking at a die, What's the probability of rolling a not 3, or not rolling a 3? What's the probability of rolling greater than 3? And what's the probability of rolling an odd? And then finally, let's say you have some marbles. You have 1 blue marble, you have 2 red marbles, 3 green marbles, and 2 pink marbles. What's the probability that you're going to pull a blue marble? What's the probability you're going to pull a green marble? And what's the probability you're going to pull a not pink marble? So go ahead and do these, pause the video, run through them, and then we'll meet back up when you are finished. All right, so for problem 1, we're looking for the probability of flipping a heads based off of what we know. How many times did a head show up? It showed up 3 different times out of how many different trials did we have? 7. So our probability of flipping a heads will be 3 out of 7. All right, what about for problem 2? What's the probability of not rolling a 3 on a die? Well, what are the chances we're not going to roll a 3? We can roll a 1, we can roll a 2, we can roll a 4, we can roll a 5, and we can roll a 6. So those are all the times we would not roll a 3 out of getting 1 through 6. So how many different options do we have where we don't roll a 3? There's 5 of them, and there's 6 total. So our probability of not rolling a 3 is 5, 6. What about the probability of rolling greater than a 3? So what numbers are going to be greater than a 3 and on a die? It's going to be 4, 5, and 6 out of our total number, which is going to be 1 through 6. So what does that become? We have 3 different choices out of our 6 total. Or our probability of rolling greater than 3 is going to be 1/2. Right. What about for odd? What's the probability of rolling an odd? What are the odds? We could roll a 1, a 3, or a 5. Out of our total number of options are 1 through 6, meaning that we have 3 different chances to roll it out of 6, or that our probability is 1/2. All right, looking at problem 3, we have 1 blue marble, we have 2 red marbles, we have 3 green marbles, and we have 2 pink marbles. What's the probability of picking the blue marble? Well, we have 1 blue marble that we can pick, and how many marbles do we have total? Well, we have 1 plus 2, or 3, plus 3, so 6 plus 8. So we have 1 blue marble we can pull out of our total of 8. What about for green? How many greens do we have that we can pull? Well, we can pull 3 greens out of, this number hasn't changed, so there's still going to be 8. And what about the probability of not pulling a pink? Well, if we're not going to pull a pink, what else do we have? We could pull a green, we could pull a red, or we could pull a blue. How many are there of all of those? Well, there's 1 blue, 2 reds, and 3 greens. Or there's 6 different options where we don't pull those pinks, and there's 8 total marbles we can pull. Or this reduces down to 3/4. Right, if you have any questions on this, email me or talk to me during office hours. Otherwise, go ahead and get started on the homework.